The next few slides is about basics about IT networking. I believe we discussed earlier what do we mean by OSI model and how traffic works since it leaves a machine or since it being processed by the application layer inside the system and until it reach to the other system or to the destination. So we are going to go through this few slides just to make sure that we are all on the same page. We are all have the same concept. So essentially, computer network is a group of devices that are connected together in order to exchange data. So the overall or the purpose of the network is to share data, sharing resources, which can help in reducing cost. Like when we differentiate between the USB printer and network printer, of course, network printer will be better because it will provide the service to multiple users at the same time, while USB printer is linked to a single device. Of course, I understand we can share the USB printer connected to one device, but at the end, we will use a network to share it as well. File sharing is another type of services that we could interconnect in a single network to do it. IPTV, online streaming, games, access to corporate services such as email, ERP system, HR management system, all of these are kind of purposes or services that you could gain if you accessed a network. So we have many types of network elements. First, we have what is called endpoint or client or user. Usually in each network, we will have two sides. The first one is the users that need to take the service, and the second side will be the service itself. So here we have endpoints, here we have server or the thing that provide a service. And in order to make users and servers connected with each others, we will need kind of network equipment. Something such as a switch, which will provide like a wired connection, or something such as wireless, which will provide a wireless connection. So in any network, we should have clients, we should have servers, and we should have network devices. And also we should have physical cables, and these physical cables could be called the media or medium. So this is the smallest, let's say, uh, smallest portion from any network. This is the essential components of any network. We should have client servers and we should have network devices and the medium that allow users to communicate with the network devices and at the end with the rest of network equipment. We may heard about many types of networks. We may heard about the LAN, the CAN or MAN, the WAN or the PAN. So local area network is similar to the network that we are currently in. It is a local, so it is linked or in other words, it is limited to a certain location or a certain area, like office, like building, something like this. For campus area network, it is similar to the network that connects the traffic light and traffic cameras across the region or across the city with each others. So it is like a local area network, but it span for a larger distance or a larger area, such as I mentioned, traffic cameras. They are all at the end connected by a network. So when they are capture a footage or capture a kind of warrants or something like this, it should communicate it to a central server to record this on the car that was imaged and violated the speed, for example. So this could be an example for campus or metropolitan area network. For wide area network, it is similar to network between countries and each others. If I have a branch in a city and branch in another city, then we have an example for a WAN. While personal area network refer to a network that could be between your personal device and each others. For example, I am using a Bluetooth headset, and this Bluetooth headset is connected to my laptop. So it is a personal area network. It is a network for my own devices that are connected together, such as the connection between the smartwatch and the mobile phone. It is also an example of personal area network. Why do I explaining all of this to you? You may consider as part of your career objective to achieve a certification such as CCNA, Network Plus, A Plus, something like this. And in these kind of certifications, you will be asked about such information. So I'm just trying to elaborate it to you just to be ready whenever you encounter such a certification or pursue a similar or tackle a similar certification. So LAN, as I mentioned, is a network that is limited to a very limited area, such as a building or office, and it offers very high speed in communication. While WAN, on other hand, is connecting branches with each others. The two locations can be in a far location. There is no option to connect direct cable between both of them, so we need to go to internet service provider, and this internet service provider would provide me with a leased line service or a direct or a special connection that can allow me to connect my headquarter with the remote branches. This connection medium, by the way, could be something based on what is called MPLS technology, could be based on a microwave tower. Are we familiar with what do I mean by microwave? Yeah, because at the beginning of my career, I thought the microwave is the microwave that we are used at home to connect the branches to each other. So I'm not kidding, by the way, but I was still young. So microwave towers looks like this. It is something that looks like this. So microwave tower is essentially like an antenna, and we place an antenna on top of the first building and the other antenna on the top of the second building. But of course, we do not use these large towers. We could use like a small microwave antennas that could be like half a meter or 1 meter at max. So what forms the internet is exactly internet is a lot of WANs connected to each others. So the internet that we are knowing is uncontrolled network. It is formulated from multiple WANs that are connected with each others. So assuming that I created my first LAN in Egypt, and then I created another LAN in Alexandria and another LAN in Cairo, all of them together are formulating a WAN. And then other country created another lands together, and by connecting these lands together, they created their country, such as UK, Finland, Egypt, Europe, anyway. And when we connected these two lands together, we got the first element of the internet. And the situation replicated in all other countries across the globe, and they started to build the connections with each others. And that's what formulated or created the internet as we know right now. The countries are connected with each other using fiber cables, and these fiber cables are placed on the seafloor in oceans and seas, which link the world together and make the internet that we know so far. So in order to understand the network communication, we have a conceptual model, which I believe we discussed it yesterday, which is the OSI model. An OSI model, as I explained earlier, it is not a model that make you in reality understand or describe how actual communication happens in programming or from programming perspective. But it helps you if you are learning about network to understand the flow of data. But in reality, when someone will develop an application, he is not writing a code for presentation layer itself and session layer itself. He could writing an application that consider all of these layers together in the same lines of code, for example. So dividing the network communication to all of these models or all of these layers has a sole purpose, and this purpose is only to teach you how things is happening in the background. So at the end, it is a conceptual model. And as we can remember, OSI model is consisted from 7 layers. We start by physical, which indicate cables, data link, which indicate local area network layer, which indicate IP addressing and how devices can communicate with each other using IP address. Transport layer, which is about TCP, UDP, and segmenting the traffic to small pieces to allow this traffic to be transferred over the network. Session layer, which track connections and keep ports open. I gave you an example which was related to web browser and have multiple tabs. And when I open a website from the first tab, the request or the response will appear on a particular tab, not in the all tabs or other tabs than the one that should receive the traffic. Presentation layer, which is responsible for encoding data, decrypting or encrypting data, convert data to binary format, and vice versa. And lastly, application layer, which presented the data in a form that can be understood by the human. So in each layer, I believe we discussed this concept and how we send the data. And when you try to apply this concept in something such as public key negotiation, in fact, you will deal with your public key as application. So you need to convert it to binary data to send it over network, and then you will send it to the IP address or destination that you are trying to reach. And then this traffic will be encapsulated inside a layer 2 frame, which includes source MAC and destination MAC, and then you will include the data. I have a question here. As we need communication, or as we need the IP, as we can inside the local network, we can communicate using MAC addresses. Why do we need IP address? At the end, I told you that if we are two devices at the same network and we have a switch in between and we try to want to reach each other, we can use the source MAC and destination MAC, right? Why we still need to use IP address? Okay, it is a concept called the protocol stack. So application layer can only segment and encapsulate the data into a container called a transport header, which can be TCP and UDP. UDP and TCP by design can only be installed or can only be encapsulated inside a header called IP header, which is the network header. IP header cannot by itself go to the outside network or leave the network interface card or move on the cable. So it will need to be added inside a layer 2 header, which is called the frame that includes source MAC and destination MAC. So you cannot simply take the data and insert it inside the IP header without installing or putting it in a transport header form. You cannot take transport header and add it inside the layer 2 frame directly without encapsulating it in the IP header. We should follow this structure when we send the data. We cannot take the transport and avoid or ignore this header. Okay? And that's what we call protocol stack. It should be stacked together. So when we receive the data, the opposite is happening, and we start to recompile the data again and aggregate and group the data again. So how OSI model can help us in troubleshooting and understanding as well. In case you have two users in the network, and this user is complaining about system outage or he cannot reach the server. So based on your understanding to the OSI model, you understood that application layer is a thing, while network layer is another thing. So we maybe have the application that is installed, such as a website on a server, is stopped, but the IP address of the system is reachable. In this case, you could conclude that the problem is related to application, not related to the network equipment. Because as you can reach the network, as you can do ping command from this device to this device, that would mean that network is working as expected. You have IP reachability. Okay? But if you don't have, so the problem could be related to faulty cable, problem in network interface card, and so on. So understanding OSI model can help you to isolate where is the issue. Of course, this is not a general situation because you may have the ping access or already enabled between two devices, but assuming that this application is hosted on port 443, can anybody tell me port 443 is related to which application? HTTPS, right? So I may have a firewall that is improperly configured, and this firewall restricts access to this port. So although I am able to do ping connection, but at the same time I cannot reach this port. So I can log into this device itself and try to open the application from it, from the local machine, if the application is hosted here. And what do I mean by application? I mean website, for example, not Office. Okay, just to make it clear to you. Office application word, I'm talking about application such as file sharing. So I would try from this machine to open the run command, and I would try to write this IP address 127.0.0.1, and then I hit enter. This IP address that you saw, or that you just saw right now, when you try to open the same IP address on your device, you are essentially opening your own device, because this IP address is called the loopback address. And as the name indicates, it is a loopback. So when you request this IP address, you return back to yourself again. If you try it from your command line interface to do a ping to 127.0.0.1, you will get a reply. Essentially, you are not pinging or checking connection with someone outside your device. You are checking a connection with your own device. If your web server or if your own device is hosting HTTP service, which means you have like a website hosted on my website right now. If I used my browser and tried to open 127.0.0.1, I will essentially open the web server that is hosted on my website or hosted on my own machine. So if I did this, the website that should appear right now is a website that hosted on my own machine. So you can simply go to this machine and try to open the IP address 127.0.0 from the web browser. If the application responded, then the problem could be related to the network, related to a firewall, something like this. That's how understanding network communication or OSI model can help you to define where is the problem. Is it network related or system or application related? Fine. So there are a lot of types of network media. What you can see now on the screen is a type of network media that is called twisted pair cables. And the twisted pair cables are type of network cables that include 8 pairs inside it. And each 2 pairs are rolled out like this on each other. That's why it's called a twisted pair. And the reason why it looks like this, because every side or every one of these copper lines have like electrical bits passing through this line, which indicates there will be like a magnetic field surrounding each one of these wires. So by modifying or by rolling or twisting these pairs together, we are neutralizing the magnetic pair, like have negative and positive power. So by twisting them together in this way, we will ensure that they will not interfere or do a kind of interference to other parts in the wire. If we have a power source that is passing on each one of these lines, and if we don't have a kind of isolation between all of these lines, we could have an issue that data that passing through this wire could interfere or could do a kind of malfunction to the bits or to the electrical power that is passing through the other lines. So twisted pair cables are twisted just to neutralize the magnetic field of each line, and in order to do so, we provide a kind of isolation. And the difference between all of this kind of cables, as you can see, at the end, all of them are twisted pair, but some of them are unshielded, some of them are foiled but unshielded, some of them are unshielded but they are foiled, some of them are shielded and foiled, which means they have like this shield and they have like a foil that protect each pair of cable. Why that is important from your perspective to understand that the here we introduce what do we mean by twisted pair cable and what do we mean by electronic magnetic intervention. Electronic magnetic intervention can reveal what is the actual data that are passing through the link. Remember, at the end, the data that are traversing the network cable is represented in 0 and 1 format, binary, right? And if I could capture these 0 and 1s, I could derive a meaning for these 0 and 1s by doing a kind of translating for what this actual data means. For example, I have an application, or I could use any website, for example, and this website, for example, I could use it and write, I need to convert ASCII to binary. I'm dealing with Google by this way. I'm asking it question by the way. So I can open a website like this one, and I can write any text I want. Then I will convert it. So that's actually what the binary value, or what is the formation of 0 and 1 that indicate this particular random text. So if I did a capturing and captured the 0 and 1s passing in a certain cable, I could translate this data back to a way that can be read by anyone. And that's what electronic magnetic intermission may mean. Electronic magnetic intermissions is like an indicators that could tell you what is the current state of data that is passing through the cable. Is it 0 or 1? And by utilizing this vulnerability in cables that use electrical power to transfer traffic, there was an operation called the AVBIL. It was during the Cold War. And during the Cold War, the United States discovered a naval base in far east of Russia. And this naval base was communicating with the central command using a cable that is on the seafloor. So one of the American submarines discovered this cable, and then they reported this vulnerability, or reported the existence of this cable, and then they crafted a special device that was placed on beside this cable. They send some submarine people who some divers who installed this device, and they took from this device like cables, and they surrounded it using the cable. And this operation lasted for like 10 years. And during each let's say 6 months or each year, the United States were sending divers or marines to capture the tapes, or the record tapes that was recording every bit that was transferred on this cable. You can imagine this? And based on this information, they understood what was the locations of the Soviet Union marine ships, what they are planning to do, and all of this stuff. All of this intelligence stuff helped the United States to counter the risk of turning the Cold War to a hot war, as we can see. So you can look for the operational EVBAIL, and the operational EVBAIL, the weakness that make it possible to intercept the traffic, that this kind of cable was transferring electrical signal, bits 0 and 1. So as this cable is not properly isolated or protected, any device can intercept or can read what is actually sent on this device. Fine? So the most secure type of device is, or cable, is called the fiber cable, because fiber cables, unlike the unshielded twisted pair or copper cables in general. And what do we mean by copper cable in general, guys? Is the cables that utilize the copper core to transfer data. So copper cable can be something like this, like the one that we use for the satellite communication, like I believe access. I believe it's called access cable. This one could be copper cable. Can you see it? Because it have a single copper core, and could be also that twisted pair cable, which we just saw earlier, which is someone like this, for example. So fiber cables, unlike UTP or copper cables, does not utilize power or electricity to move or transfer data. They utilize a kind of light, or in other words, called photons, we have what is called electron, and the electron is used in power communication and transferring data in power or in electrical format. While fiber cables are more secure because they are not producing signal that could reveal what is inside or what is transmitted inside a copper cable. So they are not subject to the risk of electronic magnetic intervention or interference, something like this. And fiber cables also has one of the benefits, which is it can go to a more far distance than UTP cables. UTP cables can be stretched for like 100 meters, for example, and every 100 meter we should have a device that is do a kind of amplification or making the signal more strong to allow it to go to go far for more 100 meter, and after 100 meter we repeat the same. But fiber cables can work for like 10 kilometers until it require another device to amplify or make the speed or make the signal more strong. Fine. Okay. In network devices, we have a lot of types of network devices. We have switches, which is connecting local users inside the LAN with each others. We have routers, which is connecting WANs to each others. So the difference between router and switch, that in any local area network, we could have, or in any building, we could have multiple floors, right? Multiple offices. Maybe we can find a switch in each floor or in each office that connect users inside this building or inside this office. And at the end, all of these switches will be connected to each other as well. So anybody on this switch will be able to reach the one on the other switch as long as we are inside the same virtual local area network or VLAN. Okay? But in order to go to the internet, I will need a router. So for the single building, I can have a single router that could allow all of these users to go to the internet. So switches are used to connect users inside the same LAN, while routers allow these users to communicate with the other world or other VLANs. Okay? We also have the access point, and the access point is another network device that allows the users who do not have the option to connect themselves to the network using the UTP or copper cable or fiber cable to use a Wi-Fi signal to connect to the wired network. Fine.